Okay, welcome back again. In this presentation, we're going to concentrate on how stars form and how they die. We'll talk about some of the main differences in the two paths that stars can take depending on their mass, and we'll also talk about nucleosynthesis and how it relates to the life cycles of stars. So stars form from a huge cloud of gas and dust. These are called a nebula. The gas from the nebula gets pulled in through gravity, and all of this gas and dust starts to form. A nebula is a large cloud of gas and dust spread over a large volume of space. Stars form in the densest region of the nebula and are created by gravity. As the gravity in the dense cloud continue to begin, it starts to heat up. And this heat makes this cloud shrink and condense into what we call a protostar. Once the protostar gets dense enough and hot enough, the process of nuclear fusion can begin. As the nebula contracts, it heats up, producing a shrinking cloud of gas and dust with enough mass to form the star. A star is formed when the shrinking cloud of the gas and dust becomes so dense and hot that nuclear fusion begins. The fusion of hydrogen into helium creates energy. This diagram shows the formation of stars. You can see in the top left corner that hydrogen gas and dust in the nebula. Then you see the gas and dust are being pulled into the center by a strong gravitational force until it becomes extremely compact and dense. This forms the core, which is extremely hot. And as the core gets hotter and hotter, nuclear fusion starts, the reactions take place and the star is formed. Stars are categorized into different categories. There's the main sequence, giants, supergiants, and white dwarfs. The main sequence of a star depends on the mass. A star's mass determines the star's place on the main sequence and how long it'll stay there. Mass is determined by the amount of gas and dust available. The most massive stars have the most energy. So high mass stars produce bright blue stars, but they use up their fuel really quickly and they only last a few million years. The mass of the star is a huge determining factor in the type of star. Again, there are the main sequence stars, giant stars, supergiants, and dwarf stars. Most stars like our sun can be found along the main sequence continuum. The mass of stars are determined by the amount of gas and dust and particles that are available when they begin to form. The stars with the higher mass are brighter and they burn more intensely, but that also means they're going to die out much quicker. This diagram is called a Hertzsprung-Russell diagram. It shows the classification of stars. In the middle, you can see the main sequence stars, and above the main sequence, you see the giants and the supergiants. Below, you can see the white dwarfs. You can also see they're classified by their absolute magnitude, which is the scale that which astronomers use to ensure the standard scale is used when determining the characteristics of stars, temperature, luminosity, and spectral class. Again, the absolute magnitude is just a scale in which all astronomers can use to classify stars and ensure consistency. Fuel for stars. The fuel is hydrogen and helium, which is converted into energy by nuclear fusion, but it also can produce heavier elements. Middle-sized or mid-sized yellow stars like our sun remain stable for about 10 billion years. Our sun is currently estimated to be in the prime of its life, which is about 4.6 billion years. The small, cool red stars live longer, and most can live 100 billion years since they use their fuel slowly. The main sequence of stars, the fuel again is fusing hydrogen into helium. But as the stars move out of the main sequence, they begin to fuse other elements such as carbon, oxygen, silicon, neon, iron, and other heavy elements. So what happens when the star dies? Well, the core begins to collapse and it gets heated. It gets hotter. The core contains then helium and it continues to collapse. But the hydrogen outside the shell starts inflating the star and the star gets bigger. It gets more massive. And if it's a low mass star, it turns into a red giant. But if it's a high mass star, remember, high mass meaning that there was more of the cloud and dust particles when it was created. So it's bigger and it creates a red supergiant. What happens next again depends on solar mass. Here you see the progression again, as on the left, all of you see is the main sequence stars and their different masses. The lower mass stars will then turn into giants, planetary nebulae, and even ending in a white dwarf. The higher mass stars move from the main sequence to supergiants, and then they'll supernova, and then they can either turn into a black hole or a neutron star, again, depending on the mass of the star. Really, really, really large supergiants will go into a black hole, where the smaller main sequence will then turn into a neutron star. So again, repeating what we've said, as the star starts to die out, it's because it's burned through all of the hydrogen and it's turned it into helium. The size of the star will determine its fate. It can either end in a white dwarf state, which is for the low mass stars, or the high mass stars can turn into a black hole or a neutron star. When the helium or when it starts to run out of fuel in the core, hydrogen and helium in the nuclear reactions, the star will start to die. Again, depending on the mass of the star, it will turn into a white dwarf or a neutron star or a black hole. Low and medium mass stars, the red and the yellow, can be up to 8 times as massive as our sun. This diagram shows you the cycles of low and high mass stars. The upper levels show you the low mass stars and the life cycle that they go through and their fates. The high mass stars are then on the bottom. So the low mass stars will start with a stellar nebula, move into an average star, a red giant, planetary nebula, and a white dwarf. Then the high mass stars then would start with a stellar nebula, go to a massive star, the red supergiant, then they're going to supernova. And after the supernova, again, depending on how large it was and how much mass it contained, it can either turn into a neutron star or a black hole. So let's talk about the life cycle of a low to medium mass star. So remember, they're going to start with a nebula, which is that cloud of gas and dust where gravity pulls it in and starts to condense into a star where fusion starts, and that's called the protostar. Then it starts into the main sequence, where as it goes through its life cycle, the fusion from the helium to hydrogen starts to condense, and then the helium starts to fuse on the outside of the core. Helium then is in the inside, and it turns into a red giant. This causes it to expand. Then you have a planetary nebula where the gas is kind of just emitted off, which leaves nothing left but the core, which is a white dwarf. So remember again, after the protostar, they go into the main sequence where they live out a lot of their life. Then they go into medium, remember the low to medium stars will go into a red giant. As the quantity of hydrogen dwindles, gravity becomes stronger and then the pressure in the core starts to shrink. The core temperatures rise, causing the hydrogen outside the shell to begin fusion. Energy flows outward, making the star expand, and atmosphere is cooling the outer regions, causing the star to glow red. So the definition of a red giant is just this large reddish star that is late in its life cycle and fuses helium into carbon or oxygen. So again, red giant is the first stage of death of a low mass star. Here the hydrogen has all burned out into helium and gravity brings the core in, shrinking it further. The temperature in the core raises, causing the hydrogen outside the shell to start fusing. Energy then starts to flow outward from the star, expanding the star's atmosphere. Then it begins to cool, causing the star to go from yellow, which is the intermediate, to red, which is a cooler star. And new elements are formed by fusion. And remember, the new elements being formed is called nucleosynthesis. After the red giant life cycle, again, this is medium to low mass stars, we go into the planetary nebula. So red giants lose this outer layer. Ultimately, it forms a planetary nebula, leaving only what's left in the center, which is the white dwarf. With the decreasing energy from the core and less outward pressure to support the star against gravity's inward pull, the star starts to collapse and a growing red cloud of gas, like a nebula, So the definition is just of a planetary nebula is this glowing cloud of dust and gas produced by a dying star, which remember is different than a regular nebula because a nebula does not have a dying star. So when the star reaches the planetary nebula, all that gas is ejected from the star, and these outer layers leaving nothing left but the core, which is the white dwarf. So the difference between a planetary nebula and a nebula is the planetary nebula will have the core left over at the end of a life cycle, where a regular nebula is just the gas and dust, which will then form into a star. So after the planetary nebula and all the gas dies off, again, we have nothing left but the white dwarf. The star blows off all of its extra mass, leaving only this hot core. So a white dwarf is a very dense star that remains after the fusion and the red giant stops, and the star will die. The white dwarf cannot fuse, and all it's doing at this point is cooling. And it's estimated to cool for like 20 billion years, which right now is longer than the current age of the universe. Our star will eventually end its life as a white dwarf. Thus ends the life cycle of a medium to a small sized star. Remember again that the mass determines the size of the star, and the mass is determined by how much gas and dust was in the original nebulae when it started to form. So as we start talking about the life cycle of a high mass stars have a greater mass than 8 times that of our sun. Early in their life, they start the main sequence just like the low mass stars. And for the high mass stars, it goes then from the nebula to a protostar, the main sequence. But here's where it goes different. Now we go into a red supergiant. Then we start into a supernova. And then depending on the mass, it's either going to go into a neutron star or a black hole. So the life cycle again is still going to start with a nebula. Here we have more mass and gravity pulls it into the core, starting fusion. As the fusion starts to occur, we go from a gas of dust and particles into a protostar because we are now forming the core. As the core starts to continue fuse, these high mass stars will also go into the main sequence, and from there it will live out most of its life. From the main sequence, then, we will go into a red supergiant. Again, this is where it differs from the low mass stars. A red supergiant is the high mass stars, again, start to die, and they become red supergiants. They are extremely large stars that create elements that are heavier in the core. In this diagram, you can see we have helium, carbon, nitrogen, silicon, and iron. As gravity overcomes the pressure in the massive stars, then it collapses, creating a dramatic supernova event. A supernova is a powerful explosion that occurs when the massive stars die. The explosion can create heavier elements than iron. So again, a high mass stars are also on the main sequence. But once they start to die, these stars are different from the low mass stars because now they enter the supergiant instead of the giant stage. These supergiants are extremely large and create nucleosynthesis, through nucleosynthesis, heavier elements such as iron. The gravity will continue to grow until the final collapse in a huge explosion called the supernova. These supernova are powerful explosions which can create even more of the heavier elements through nucleosynthesis. So in the last slide, we talked about a supernova, but here we'll talk about it again. So the elements get ejected into space after this huge explosion, and eventually they become part of another solar system like ours. The iron that exists on Earth today is believed to have come from a supernova that occurred billions of years ago. So when the supernova event occurs, all of the elements will get ejected again and wander into space. So again, the end of a high mass star comes as it tries to fuse the core of iron into heavier elements. And finds this absorbed energy. The star collapses and explodes as a supernova, and the elements created spread out from that explosion. So here's another picture of an actual supernova caught on film. You see on the left, the before the star exploded, and on the right, in 1987, you can actually see that huge explosion taking place. So next, we're going to talk about a neutron star. So remember, I told you that after a supernova event in large mass stars, it can either turn into a neutron star or it can turn into a black hole. This again is determined by the mass of the star. So if it is one of the smaller of the large mass stars, it'll turn into a neutron star. So if the mass after the supernova is less than 3 times that the sun's mass, the star will die as a neutron star. A neutron star is a dead star with the density of an atomic nuclei. Neutron stars are only a few kilometers in distance, but are so dense that they sometimes are detected as pulsars. Pulsars are a rapidly rotating source of radio waves given off by rapidly rotating neutron stars. So again, in large mass stars, after a supernova event, if the mass is large enough, it will create a black hole. A black hole is an object that is so massive that not even light can escape its energy and its gravity. Black holes are observed indirectly because there's no way to actually see the light that would light it up. So we see the influence of objects around them. Below you can see the animation of the effect of a black hole. So as we've been talking about nucleosynthesis, here's just another definition for you. Remember, nucleosynthesis, synthesis is putting something together, and nucleo, we think of the nucleus. But this is the formation of elements. So except for hydrogen and helium, and we believe that was again created in the Big Bang event. All the other elements, though, are created by fusion in the process of stars. So stars are said to evolve with changes in the abundance of the elements within. Here again shows the different fusion and the different elements that are caused from a red supergiant star. Here is a table that shows you the summary of the elements that are produced and by what star produces them. So again, you start with the main sequence stars, and in the main sequence stars, what you see is hydrogen, which is burning into helium. A red giant, then, we have helium, that burns to carbon and oxygen. So remember, a red giant comes from the small to medium-sized stars. Then if you look at the supergiant, at this point, it's moved off the main sequence, so it's in its dying stages, just like the red giant. But a supergiant is a higher mass star. Now we have carbon, oxygen, neon, and silicon that is going to start producing iron. Okay, then in your supergiant through supernova, now you're going to start getting many of the higher and heavier elements. So remember the hydrogen to helium, helium to carbon and oxygen, and carbon and all through iron. All of those are created through nucleosynthesis and fusion, whereas the higher mass stars of the heavier elements are created through the supernova. So this again just shows you kind of what we saw in the last slide in the table. So you have your stellar nebula, and then we move into a protostar, and both of them, either high mass or low mass, will go into a protostar. From there, if it is a low or medium mass star, we go into an average star. Here we're going hydrogen into helium. Then, as it starts to die, we move into a red giant stage. Here you can see that the star has gotten bigger, but it's also cooler, and the color is red. Now we're fusing into carbon and oxygen. All of that then is being ejected through the planetary nebula, and it will end in a white dwarf. If we choose the path of a high mass star, again, we start with a stellar nebula, which we go, again, by the mass of the dust and the gas particles around, which is being pulled in by gravity. We go to a protostar, then we go into the main sequence, where again, we're going hydrogen into helium. But now, as we start to die, we're going to go into a red supergiant. So we have neon through iron. From there, we're going to have a massive explosion where we're going to create many heavy elements, and this is a supernova. Depending on the size of that supernova, if it's smaller than 3 times the mass of the sun, then we'll go into a neutron star. If it's larger than that, then we'll go into a black hole.